Hello guys, welcome to V-Numerical. So in the last video, we spoke about, how can I say, infinite. We deduced, okay, we demonstrated a real infinite, like real, we demonstrated how to find infinite roots of a homogeneous high order differential equation, okay? Now, today we are going to find how to find in case it is real, okay? But this is repeated or equal roots. Suppose we have an homogeneous differential equation. Why is it homogeneous? Because here it is equal to 0 and all the terms here are lying in y, okay? We spoke why this is homogeneous and so how to solve this kind of equation when we have what is the real infinite equal, okay, roots. When this guy has infinite root, because we have solved for infinite different roots, okay, and the formula or the general term that we got was like CF is equal to Euler raised to M1x, okay, times C1 plus Euler raised to M2x times C2 plus infinite sum plus, okay, Euler raised to Mn x times 2 Cn. This is when we have like this root m. M is first root, is different from the second root, okay, okay, and this is different to n root. They are all different. When we have all the roots different, and this root, okay, and m is belonging, okay, m belong to real numbers, so the solution for that homogeneous, for this homogeneous, okay, for this homogeneous, I will write here this homogeneous differential equation, dx raised to n, and here raised to n, like an plus an minus 1 dy n minus 1 upon dx n minus 1 plus infinite sum of a1 dy dx plus y equal to 0. When we have this expression here, the solution, okay, when we have this homogeneous differential equation with constant coefficient, a, okay, constant coefficient, okay, the general solution, if this homogeneous equation, okay, the general solution will be, for the homogeneous equation, will be this one directly, okay? Just solve, find what will be your m, and that's all, and solve for those one, okay? This will be the general solution. When we have different, I will speak again, when we have different and equal infinite root, this will be the general solution. But now, see, how if they are equal infinite roots? How to find the general solution for this one? Okay, that's the point. Let us just solve for this one. Okay, that's the point. How to solve. See, for how to find this one, infinite roots. See, here I have just one example. We will use a basic example to deduce the general formula. Now see, here I have y dash, 2y, and plus y, and so on. The first thing we are going to do here is like y, we are going to put, okay, put y equal to Euler raised to vt, not vt, vx, okay, where this x is the independent variable. So here I'm assuming that f of x, okay, y is a function of x, okay? I'm assuming that y is a function of x. So here the independent variable will be x and the dependent variable will be y, okay? It can be t, can be r, can be whatever you feel like, but I assume that it is x. So that's why I put here x. Then just put y equal to Euler raised to vx, where v is a constant, a number, okay? V is a constant, as we did last time, okay? Now, what we have to do now? Now, okay, now we have to find what is y dash and what is y double dash and substitute in this. So substitute in this. Y dash will be Euler, okay, will be v raised to this vx. Now y double dash will be v, okay, v square Euler vx. Just derive. Now that you found what is y dash, y double dash, what's the next step? I will substitute this expression in this equation, okay? Substituting what you're going to have v square Euler vx plus 2 time, okay, time v Euler vx plus Euler vx equal to 0. Isn't it true? Yeah, it's true, because this one is y double dash. 2 times y dash. Y dash is this, 2 times y dash. Then y is this one, okay? This is y, then substitute in this one. So substitute. Now we have just find this equation. Now just factorize this one. This will be Euler raised to vx, okay? Then, okay, v square plus 2v and plus 1. This is equal to 0. Now we come to the same problem, like this one cannot be equal to 0. So as long as I find the value of v and substitute in this equation, or in this part here, if I found the value of v, substitute in this one, then if I put this value, just put this value of v here and substitute in this expression, you will get the solution directly of this differential equation, okay? As here we will have 2 values of v, so we will have 2 also. We will have this one and the second one, okay? Now see. Okay, this one will be impossible to be 0, but this one can be 0. So I'll pick up this one, v squared plus 2v plus 1 equal to 0. We know that here, this one is the sum, the addition of 2 roots. This one is the multiplication of the roots. So this is 1 times 1, and this is 1 plus 1. Yeah, just easily you can see. So it means that v1, okay, v plus 1 square is equal to 0, right? If v square is equal to 0, it means that here I have v is equal to minus 1, but this v equal to minus 1, it is repeated twice, okay? So it means that this guy is, let me write down with a different pencil, like it is repeated, okay, twice. See guys, it is repeated twice. So if it is repeated twice, what does it mean? It means that here I will have surely CF will be equal to the first solution, okay? I will have the first y, okay? My first y will be directly what? With the first one, y1 will be this one, substitute in this, Euler raised to minus x. Why minus x? Because y is equal to vx, right? So y1 will be for the first one, this will be what? Okay? This is repeated, okay? Yeah, this will be y1 is equal to vx. So here I know v is equal to 1. So it will be Euler raised to minus x. Nice? So Euler raised to minus x is my first solution. Okay? It's my first solution. Now, what should be my second solution? Because here I have 2. The order is 2. It means that I have 2 solutions compulsory. So y2, what will be my y2? That's the question. To find y2, you have to reduce the order of this differential equation. And reducing order of this differential equation is what? Is just by adding a function of x multiplied by the first solution that you have. What is the first solution that you have? Euler raised to minus x. The first root, Euler raised to minus x. So this one, minus x. Okay? That's the point. And see, what we are going to do is just to find what will be this u of x. Okay? What will be this u of x, so that we can just put it all together. Because we know dot CF is equal to all of them, like y1 plus y2, okay? That's the point. Now, what is my y2? That's the question, okay? Y2 is this one that we are going to find by reducing the order of this differential equation. So u of x times u raised to minus x. How to find them? My u of x. That's the point. So to find my u of x, I will just divide this square, okay, the board here. So to find what is y2, okay, I said that y2 is u times u raised to minus x. Do not forget that u is also a function of x, okay? See, what we have to do, we have just to find what is u. This is y, okay, y2. Now we have to find y dash and y double dash, then substitute in this. When we substitute in this, we will be finding this u. And when we find this u, it will be easy to us to find these ones, okay? Just let us solve what is really important. See, y2, okay, y2, what will be our y2 dash? Y2 dash will be this derivative, this will be u derivative, and u raised to minus x, plus, okay, plus, then I will derive this as second expression. This u will remain the same, u, and when I derive this u raised to minus x, it will be what? Minus u raised to x, negative, okay? So it will be minus u raised to minus x. Nice. Now that we have here, I have to find y double dash of the second solution. Y double dash of the second solution, what will it be? It will be this guy derived twice. Okay, I have to derive again this one. Okay, I will derive first this one. This will be u double dash u raised to minus x minus, again, u dash u raised to x. Then plus, okay, this expression, right? I'll put minus. As you see closely, this expression here, if I derive, is the same that if I derive this one. So the derivative of this one is this one. So I will just repeat this term down here. Okay? U dash u raised to minus x, then minus u and u raised to minus x. Okay? That's the point what I'm doing. Okay? Now it means that u double dash, y double dash will be u double dash u raised to minus x minus this and this, minus 2u raised to, minus 2u Euler negative raised to x, then plus u Euler minus x. Okay, now that I found what is, my, let me see, this is, what is my y2 double dash, and what is my y2 dash, and now that I know what is y2 only, all I have to do is just to substitute then. Okay, I will just substitute this in this. Okay? Okay, I will put the step 1. This is the second one. Okay, second. And this is the third step. Okay, guess it is understood by you. Now see, I will substitute just this expression in this one. So let me substitute. What will it be? It will be like where I have y double dash, I will put this one. This will be u double dash Euler minus x minus 2u, okay, minus 2u Euler minus x plus u Euler minus x. This is y double dash. This is 2y, okay, plus 2y. What is y? We know that y2 dash is this one, u dash Euler minus x, then minus u Euler minus x. That's okay. Okay. Then plus, okay, plus y. Y we know, y2, just substitute in there. What is y2? U Euler minus x. And it's equal to 0. Okay? And it's equal to 0. So now what should we end with? See, I just substitute in this. I will just put together all the terms, all the double dash together. I'll get u double dash, okay? Euler minus x. This expression right here, okay? This is 2, okay, 2u. This is dash, sorry, okay? We don't have to forget, this is dash. As you can see here, 2u dash, okay? Dash, dash, okay. This minus 2u dash, minus 2u dash, Euler of x negative of minus x, okay? Plus u times Euler raised to minus x. Plus, now I just do this one. This will be 2 u dash Euler minus x, and this minus 2 u Euler minus x plus Euler raised to minus x. Now see this expression right here, okay? This one, just checking, okay? Just by checking, you see that this one, this expression right here, is equal to this one. They will be cancelled out, okay? This expression right here, if we just put this and this one together, this and this will be 2u Euler raised to minus x. And here minus 2u Euler raised to minus x. They will be cancelled out also. What will I remain with here? I will remain with only u raised to u double dash Euler minus x is equal to 0. Now see, that's the question. See, when we have this one, okay, again, Euler minus x equal to 0 makes no sense, okay? That will make no sense. You can just put it away. So we will have, let me use this one, this expression here. U double dash is equal to 0, as Euler minus x is also equal to 0. Euler raised to minus x is equal to 0. But see, this expression will never be equal to 0. So we can forget this expression here. We will take only what is u. Okay, we will take what is u. So it means that u double dash is equal to 0. Now, how to find what is my u? Because my intention here is to find what is u. Okay, so that I can write the second solution. Okay, so u, if I want to find what is u is a function of x. It means that whatever I have here is also a function of x, even though if it is 0 or something like that, it's a function of x. So Euler derivative, if I derive a function of x, it will be a function of x also. So then, if I want to find what is u, I have to apply integration. Okay, I have to integration. Okay, first, find the first integration. It is the same as I wrote something like this, d of u dash, okay, that will be equal to 0, okay? So 0, with respect to what are you integrating this? This is a function of x. U is a function of x. So this integration here in the other side will be integration with respect to x, okay? Now you get something like this. If you integrate this one, it will be u dash equal to 0 plus c. Because integration of 0 is 0 plus c. So it will be only c. Now that you have found this one, this is u dash. I want what is u, not u dash. Then I integrate again, and I integrate again. This with respect to x, and this one I integrate again. So when I integrate this again, what will I get? U dash will be the same as integration of d du. And here I will get c dx. So what will it be? It will be what? It will be u will be equal to x times c. Okay? As you can see. So u is equal to x times c. So as this is the second solution, I can say that u is equal to x c2. Because c1 we have already here. Okay? We have found already c1. Then this one will be c2. So what we have to do now? We have just to substitute where we find u in this expression. We will substitute xc and put there xc. Okay? Put there xc. Okay, now let me substitute in this. Okay, as I told you guys, so what we have to do now that we found, okay, what is y1? So CF, the equation is y double dash plus 2y dash plus y equal to 0. The equation will be, what is y1? Y1 we have already found. Let me just show you, okay. This is your y1, Euler raised to minus x. By finding y1, it's just substituting the solution, the equal solution that you have in there, in this expression. Then you find y1, just like this. Now, to find y2, you have to just go through this process that you can see here. Okay? So, to find y2, we have to reduce the order of this differential equation. By reducing the order of the differential equation is what? Is adding another function, okay, of u. And this u, you will just go to find what is this u of x. And after finding this u of x, put in there. And we have found this u of x. And this u of x is nothing more or less than this expression right here that you can see. This is u of x. Then substitute this in there, and you are going to have your solution. So how can I write? So the solution will be Euler raised to minus x times C1 plus this y2. We say that y2 is u times Euler minus x. So Euler raised to minus x. What is u? We said that u is x times C2. So it will be x times C2 times Euler minus x. This will be the solution. So CF will be Euler minus x C1 plus x Euler minus x C2. Now check this, okay? We are going to find the general solution for this one. Check this, okay? So CF, when when the roots are real and equal, will be Euler raised to minus x, okay, C1 plus x C2. Now see, just by checking, you can see that, okay, here we have only one root that is equal, all are equal. Now to find the infinite equal roots when they are equal, the infinite equal root for this equation, what will it be? It will be CF. Okay, as the root is the same, I will put Euler raised to m, okay, only m, x time to C1 plus x, C1, x, C2. If it were third order, it would be x square C2 plus infinite plus, you see, as you can see, it will increase till infinite. Then we can just write down here, okay, for any order, it will be x raised to n minus 1 times Cn. Okay, this will be the solution of this equation. So this is the solution of a higher order, homogeneous, linear, constant coefficient differential equation when we have infinite equal roots. Okay? When we have infinite equal roots. I will write down here just with another pen. With another pen. So like CF is equal to Euler raised to m of x, because m is only 1. And this will be C1 plus x C2 plus infinite plus x raised to n minus 1, and here Cn. Okay? Yeah. This is the general solution when we have equal